Okay, so we had a question about this trig equation. Tangent of theta is equal to -1, and so we're going to just take a look at this and see how we solve this and how we solve these things in general. I'm just kind of assuming here that maybe theta is supposed to be. I didn't see the actual problem statement, but just let's say theta is supposed to be in 0 to 2 pi. That's the standard interval for solutions of these things. So first step is to say, all right, well, what is tangent? Tangent is sine of theta over cosine of theta. We want this to be equal to -1. So this thing, tangent of theta is equal to -1. That's true. This means if and only if. Down here, it's true if and only if sine of theta over cosine of theta is equal to -1. That's true, of course, if and only if sine of theta is equal to negative cosine of theta. So we multiply through by both sides by cosine of theta, and now I'm trying to figure out here where sine is equal to negative cos, where sine and cosine have the same absolute value but opposite signs. One is positive and one is negative. And so hopefully I know from my special triangles that sine of pi over 4 is equal to root 2 over 2, which is equal to cosine of pi over 4. And this of course comes from, we'll do it quickly down here, this special triangle where I have here pi over 4, pi over 4, 1, 1, and square root of 2. And then just the definition of sine and the definition of cosine. And also, hopefully I know from the unit circle, which we're going to look at presently, and the special triangles, of course, and the unit circle are the tools that we use to do most things in elementary trig, including solving basic trig equations like this. I know, hopefully, that if I make this angle theta with if I have this terminal, I'm making this angle theta with the x-axis, then the coordinates of this point are cosine of theta and sine of theta. And the reason, I should maybe either put brackets around both angles or neither. I'll go with neither here to save space. This is of course because if I drop this perpendicular line down here to make a right angle, well, this distance is the y-coordinate of the point, and this is the unit circle. So the length of the terminal arm is 1. So sine of theta is equal to, if this is the y-coordinate, if this is the x and this is the y-coordinate of this point, sine of theta is equal to y over 1, which is just equal to y. Same thing if I look at the x-coordinate, this distance over here, I see that cosine of theta is equal to x over 1, which is just equal to x. So let me unwind this, and sorry, so the next thing is that we, because I just want to review this quickly in case people had trouble with this because they didn't know how to do this step. If I make an angle of theta, say here, well, I look at the same, and I want to figure out what are the coordinates of this point. I look at the same values, cosine of theta and sine of theta, where theta is this angle, but now I'm rotating all the way around here to make an angle, that same angle of theta, with the x-axis in the second quadrant here. Well, I look at now, where am I in the plane? I'm here in the to the left of the y-axis, so the cosine value of the point has to be negative. The x-coordinate has to be negative. If I come down here and make an angle, I think they call this the related acute angle. The principal angle, I think they call it, is going all the way around here. So I rotate all the way here to make this angle theta in the fourth quadrant. Now the coordinates of this point, again, it's going to be cosine theta and sine of theta, but I have to think, where am I in the plane? I'm to the right of the x-axis, so the cosine stays positive, the x value stays positive, but I'm below the x-axis, so the sine sine value, the y-coordinate is going to be negative. And this procedure, this process, is the key to solving this equation, which hopefully we haven't forgotten about up here. Tangent of theta is equal to -1, or sine of theta over cosine of theta is equal to -1. Because the idea is that I'm going to know that sine of pi over 4 is root 2 over 2, which is cosine of pi over 4. So the idea is that I'm going to try to figure out where I can put this related acute angle of pi over 4 so that the sine and the cosine will have opposite signs, and then figure out what the principal angles are, the corresponding principal angles are. And I'm going to pick the ones that come from this interval from 0 to 2 pi. I could be doing from negative pi to pi. There's tons of different intervals where I could be picking my solutions, but I think probably the best one to illustrate it with is at least beginning with 0 to 2 pi. So let me do that right now. I'll just draw another unit circle down here. And let me center it on the axes. Great. Okay, so I know that if my angle here, my theta is pi over 4, this is going to be root 2 over 2, root 2 over 2. So cosine of pi over 4, let me draw it a little bit neater, cosine of pi over 4, sine of pi over 4. So here they're equal, but I don't want them to be equal. I want them to have the same absolute value, but opposite signs. I want one to be the opposite, or I want one to be the negative of the other. And since I know that cosine is the x and sine is the y, I can achieve that result by putting it either here, pi over 4, when I'm in the fourth quadrant, when I'm below the x-axis, so sine, the y will be negative, and to the right of the y-axis, so cos, the x will be positive, and also here, if I put my related acute angle there, I'm to the left of the y-axis, so the sine, the cosine, the x will be negative, and above the x-axis, so the sine, the y will be positive. I think I said that right. Hopefully I said that right. So these are well, that's a terrible choice of highlighting color. There we go. These are the related acute angles that I want. But and so the coordinates of this point, of course, are going to be negative root 2 over 2, root 2 over 2, and root 2 over 2, negative root 2 over 2. And so the last step is that I just have to figure out what are the principal angles, how far did I have to rotate around going counterclockwise from the starting position of the terminal arm, which is flat across here at an angle of 0 or 2 pi at the point 1, 0. How far did I have to rotate clockwise to get to this point? Well, this one, I can think of it as going all the way over by pi, and then coming back by pi over 4 to get that related acute angle. So this one, the principal angle is going to be pi minus pi over 4, which I'm pretty sure is 3 pi over 4. I've been known to mess these things up, but I'm pretty sure that one is correct. And let me just get rid of these arrows, so it's, well, not the whole circle, just the arrows, so it's not as cluttered. What about this one down here? Well, if I want to go counterclockwise and get to there, like that, I can again think of going all the way around by 2 pi, and then coming back by pi over 4. And again, I'm just going to sort of take a leap of faith here and say I think this is 7 pi over 4. I believe that's 7 pi over 4 here. So this gives me, and because these are kind of weird, let me get rid of these arrows again, because it's very cluttered. This means that theta is going to be equal to 3 pi over 4 and 7 pi over 4. And again, this was assuming that theta came from 0 to 2 pi. If say I had been asked to find it in, let's do a different color, I don't know, this really dark, ominous color. If, say, instead theta was coming from negative pi to pi, what does this mean? This means that I can only go forward to pi, or backwards by negative pi. That gets me the entire circle, all the possible values of sine and cosine, because I start at this point and end up at this point. I just go in different directions around the unit circle. In that case, I'd be keeping the, let me do it in the same color to make sure the association is clear. In that case, I would still be doing the 3 pi over 4, because I'd be coming 3 pi over 4 in this direction towards pi, but this one now would be negative pi over 4, going clockwise. Negative angles go clockwise, of course, from the x-axis, so that would be negative pi over 4. So hopefully that answered the question and wasn't overly confusing.